Hello, and welcome to my presentation on analyzing housing prices for the real estate market. My name is Eshan Jain. So my personal interest in it is that my entire life, I've always been interested in the real estate market. What I really love about it is that it's an open place that anybody can invest in, and the investments can make impacts on people's day-to-day lives. It is also a very versatile market, because those who choose to invest can either take a very active role or a very passive role in their investments. I chose the Zillow downloaded dataset because it provides real-time housing prices over the past 20 years, which is a large enough time frame to get insight about past and possibly future housing prices. I also chose the geographic and population datasets because I believe that they are some of the biggest factors on influencing housing prices. From my analysis, I'm expecting to find that geographic location, population density, and homelessness rates are highly correlated with housing prices, meaning that they play a big factor in determining what the housing prices of different areas are. So I chose my first data set because Zillow's data provides the average housing prices of major cities across all of the United States for the past 20 years. I found Zillow specifically because when I was researching different data sets, it was one of the few free real estate data sets available, as most of the companies collect such data to sell it for commercial use. Similar to my first dataset, for my second dataset, it was also difficult to find an API that provided free usage of their data. But the data from census.gov was both free and perfect for my usage, because it provided the latitude, longitude, and area of different states. For my third dataset, I chose to use the World Population Review because it was one of the few sources that had the data organized in a table rather than for download, which made it perfect to be web scraped and used in my analysis. Now for my data cleaning process. For my downloaded data, I began with loading the CSV file using pandas read_CSV function. I then replaced any missing values with np.nan so that I could use them for future calculations without error. I then removed any unneeded columns and replaced the region name column with just the city names. Finally, I created a new column that contained the calculated average percent changes over the past 20 years for each city. For my second requirement, the API requirement, I began by requesting the JSON file using the API key given to me by census.gov. Using census.gov's documentation, I was able to figure out which parameters I needed in order to get the latitude, longitude, and area of each state. To clean the data, the first step was to turn the first row of the table into the column names and the rest of the data to the actual data. After that, I removed the District of Columbia and Puerto Rico from my data so that it matched the rest of my data sets. To create a new column that contained the region that each state is in, I created a function and applied it across each row using the longitude and latitude of each state to categorize it. And to clean the web scrape data, I began with using the request.get function to collect the HTML code from the first website. I then created a beautiful soup object using the HTML data collected. I then looked for the table tag using the object and then iterated through the table text using the TR and A tags. This data was then added to a new Panda data frame, and the columns of the data frame were renamed correctly. This process was repeated for the second website as well. Both the websites were created by the company, so the overall structure of the HTML code was the same. I then merged the two Panda data frames together on the state names so that one data frame contains both the population densities and the homelessness rates. Now for my analysis, insights, and visuals. To give my first insight, I began with grouping the cleaned out downloaded document dataset by the state names and calculated the mean of the average monthly percent change columns for each state. The grouped columns were then sorted in descending order. Indexes were reset and the columns were renamed. The percent values were then reformatted to match the standard percent form for visuality purposes. From this table, I learned that different states have huge differences in the percentages that their housing prices have changed over the past 20 years. Hawaii's housing prices have increased by 55.82%, while Louisiana's prices have only increased by 13.95%. For my second insight, I began by calling Insight 1 to use the average state percent changes that were calculated in Insight 1. I then changed the percent value so that it can be used for calculations. By using the z-score function from the SciPy library, I calculated the z-scores for all of the homelessness rates and average state percent changes. I then compared each z-score to 2, which represents a 95% confidence interval, to determine which values were outliers and displayed all the rows that had an outlier in each column. From the display table, I determined that states that have had significantly low increases in housing prices tend to not have homelessness problems, which makes logical sense. But states that do have homelessness problems have not necessarily had a large increase in housing prices. For my third insight, I began by calling insight 1 again to retrieve the average state percent changes. I also called the clean web scrape dataset, which contains the population densities of different states, and I merged the two datasets together. I used the Pearson R function from the SciPy library to conduct a regression test on each state's average percent changes in housing prices and its population density. From the test, I found that there is no statistically significant correlation between the state's change in prices and its population density, as the correlation coefficient was only 0.1750. This is important because I initially thought that a state's population density is a good indicator of how housing prices have changed, but I realized that they're not. Visual 1 is a scatter plot representation of the average state percent changes in housing prices and the population densities. With the population densities on the x-axis and the change in prices on the y-axis, the scatter plot shows that most of the points do not follow the regression line, meaning there is little to no correlation between the two variables. For my fourth insight, I began by calling the entire clean downloaded dataset. I then ranked the percent change in the housing prices and the most recent price for each city in descending order. I then used the Kendall-Tau function from the SciPy library to conduct a Kendall-Tau correlation test, which calculated a tau value of 0.4216. This means that there is a statistically significant positive association between a city's average monthly change in housing prices and the current population. Visual 2 is a scatter plot that represents each city's average percent change in housing prices and its most recent average price. With the ranks of the percent changes on the x-axis and the ranks of the recent prices on the y-axis, the scatter plot shows that most of the data points are close to the regression line. For my fifth insight, I began by calling the clean downloaded dataset and grouping the most recent prices by state and aggregating them using the mean function. I then called the clean API dataset and merged the two datasets together. After dropping unnecessary columns and converting the averages, I grouped the average recent prices by their regions and applied the mean aggregate on them again. These values were then rounded to 2 decimals to properly reflect price values as shown. Visual 3 is a bar graph that represents the different average prices by region. By looking at the graph, it is clear that the Midwest and West regions have higher average prices than the Northeast and South regions. While conducting my cleaning and analysis of different datasets, I learned how to conduct statistical tests on data using Python. By using the SciPy library, I was able to conduct a regression test across an entire column simply, something that would have otherwise taken me a long period of time to do. I also used the matplot library for the first time. Even though we had learned it in class, I'd only used Plotly, so it was new. I also learned some insights about the real estate market. I learned that while population density of a state isn't a good indicator of past or future housing prices, looking at the current price of a state and comparing it to others is a good indicator. One of my most unexpected challenges was working alone. The workload of the project itself wasn't too much, but it was difficult to make decisions about what datasets to use and what insights to make without having anyone to discuss it with. Thank you.